Hello, Professor. My name is Erdoğan Ege Kavlak, and this is my project topic. As you know, GPS doesn't work well indoors because signals get blocked by the walls. Usually, solving this requires expensive hardware, but I wanted a cheaper solution using the existing Wi-Fi network. For in this dataset, which consists of data collected specifically in the indoor environments. My main goal is to data. My main goal is use this data to perform accurate indoor positioning. However, since Wi-Fi signals are inherently unstable and noisy, simple algorithms are not enough to solve this. I processed this raw data with statistical methods and trained a machine learning model. In the final stage, I will convert this model to RESTful. I converted this model into live RESTful API that gives the real-time location results. Dataset is collected by the Jadavpur University, which is this university is at the India, and they designed for specifically designed for the indoor positioning research rather than the using synthetic simulations. The dataset contains of signal strength of data collected from 105 different access points. In terms of model structure, we use this 105 signal values as our input features. For the output, the model aims to predict the specific room label where this device is located. Since our goal is to identify the correct room out of many possible options, this project is technically defined as a multi-class classification problem. And I want to show my project. Firstly, I downloaded this data to my computer, and after that I turned the Excel file to CSV. And this is my code blocks. Firstly, it cleans the data, it removes the duplicate rows that fill missing values with the 110 dB because which is mean there is no signal. It also removes room that do not have enough data. After that, feature engineering, because instead of just using rough signals, it calculates a statistic like the average standard deviation. This helps the model understand the signal quality better. And after that, we are preparing the data for training. It converts room names into numbers, splits the data into the training testing groups, and scales the values so the model can learn easily. In this section, I worked the data with feature engineering. Without feature engineering, we have the option. And I wanna show my training parts. I'm running my code firstly because I wanna show the results. In the training phase, I didn't rely on the single algorithm. I created a competitive testing environment to find the best solution. I trained and compared 4 different machine learning models on the same dataset. These are KAN, random forest, support vector machine, logistic regression. This is our results: accuracy, F1 score, time. For the results, the KN was the best performing model for this specific Wi-Fi fingerprinting data. Finally, the system automatically selected and saved the best model to use the Live API. And also I created the some comparison PNG I added to my report. You can see there. And the time is connecting to API. After training the best model of KN, I need to way to use in the real world scenarios. So I built a RESTful API using a fast API framework. This system, it accepts the live Wi-Fi signal data from a client in JSON format, and inside API this raw data goes through the exact same prep processing and feature engineering step as our training data. Then the train KNN model predicts the location and return the room label. To manage entire project easily, before this main code blocks, this is my API code blocks. In here, API get function, post function, delete function. And I create a main, and I want to show the main function. This files as a control center of my entire project. It's running multiple Python scripts one by one. It's difficult and confusing. That's why I designed the simple command line interface. When I press the first one, it's coming up like this screen. When I enter first one, it trains the model. If I click one to visualize the data, if I click the third one, it comes address and the Swagger docs. I will show. We have post, get, and delete functions. The predict, it predicts, executes. This is response body and response headers. Get all records. I can see the what I want, how many data. If I write one, I can get just only one. If I write 20, I can see the 20 data in here. And if I want create a new one, I can enter the values and I can create a new data, and I can delete. I would like to show an example. This is index HTML page. This is front end of the system. This screen the user sees. Here's in the terminal. As we can see, the system is working and running. I want to show some example. This is my front-end page. As I said, before recording this video, I extracted some samples from the dataset because data need to be comma separated. I use the AI. I use the AI assistance for the that part. It works system, as we can see, it works. And I have one example. And also it works. This is my project. Thanks for everything. Thanks for listening.